Hello and welcome. This is T-Minus Today. My name is Dave, your host, and today we're going to be talking about GTC. It's the GPU Technology Conference that NVIDIA had on the 14th of May 2020. So this is going to be talking about new technology that's coming out for NVIDIA GPUs. This is not a gaming video. So these aren't gaming GPUs. These are GPUs for the data center and AI and machine learning and deep learning, so we can get better stuff later. And there's a lot of AI that's creeping into our day-to-day, especially for gamers. So NVIDIA, actually, we're just going to pull it up and then we're going to take a look at it together. So here we go. So this is the first thing I'd like to talk about. They have this image here. It's native 540p. It's rendered. And what they're going to do is they're going to upscale it using something called DLSS. Now what DLSS is, it's this, they have a machine learning algorithm in the background. This is AI that compares this native 540p image with an image that's, I think they said 16K. It was huge, this huge image. And then they compare and go over iteration after iteration, and the machine learning algorithm gets better at faking high resolution images. And one of the reasons they did this is because they have this thing called RTX. It's ray traced graphics. And what this does is gives you dynamic lighting and things. So it traces the rays, so as it bounces from one object to another. So if you have a red object and light shining on it, the red will actually bounce to another object in real life. So we're simulating that in real time, and that's very difficult to do. So what we're doing, or the tricks around it, this is a really cool trick actually. So DLSS 1.0 wasn't very good, but DLSS 2.0 is getting much better. So they have a 540p image, which is fairly easy to create, and then they upscale it using DLSS to 1080p. And here's kind of what it looks like. So this is the native image that they were showing, and then they're going to upscale it using that AI processing, that background processing, to 1080p. It looks way better. So you've got your native 540p and then upscaled to 1080p. They were saying it looks almost better than the 1080p image native that you get. That's pretty cool. And then, of course, they had to show off their RTX graphics. So with Minecraft, got your RTX off, RTX on, RTX on. You got these cool dynamic lighting. See how the light bounces. Yay! So this isn't like full ray tracing, but it's pretty cool. They did a really good job. It looks awesome, in my opinion. So for the meat and potatoes of the conversation, they announced the NVIDIA A100, and this is a 7nm chip on TSMC. So this is kind of what you're going to see in the future. It's on HBM2. It has 54 billion transistors or something. It's giant. It's got tensor cores. It's got this MIG configuration. I can't remember exactly what that stands for. But what it does, you can break up the GPU into 7 separate GPUs when you're doing it for computing. Pretty cool. We're going to skip through it a little bit more. Okay, here they were showing actual numbers. So FP64, I think, is a really good number to look at, is 8 versus the A100 gets 20. This is the kind of performance that you're going to see in GPUs coming out. I mean, you're going to get 50% or more out of this next generation for sure. You can pretty much take that number, the 8 and the 20, calculate. I guess we could do it right now if we wanted to. So 8 divided by 20 is 40%. So it's going to be 60% faster than last generation. And I think that's a pretty good number. I'll stand by that. That's like peak performance. That's the best of the best. Might be about 60% faster than last generation, because they did do a node shrink, and that's pretty cool. Okay, so here's a little video that they did, just taking a look at the A100. This is the giant processor board. It's pretty amazing, really. It's well engineered. I think it's going to sell very well in data centers. He talked about a couple things. It's a scale up and scale out. Now, what scale up is when you're scaling up an environment, you add just capacity. So if you have like an array, like a SAN, you're going to have a DAE, like a disk array enclosure, and you have like your disk processing enclosure. So your disk processing enclosure is the base piece. Then on top of that, you have your disk array enclosures. And when you just add an array enclosure without extra compute or networking or like memory and stuff, that's called scale up. But when you add all of those things, the network, the compute, the memory, and storage all at the same time, that's called scale out. So he said that it was going to be both a scale up and scale out solution. So today's data center, you've got all these systems, and wow, it's 1/10 the cost, 1/20 the power. Take those numbers with a grain of salt, but that is pretty impressive. I mean, it is a huge leap forward, and people are going to be buying these up in droves. $1 million for a rack that has that kind of computational power is not that much in the enterprise sector. When I was working for Mosey, we purchased like $60 million worth of racks. It was like, well, I think 48 racks or something. It was a giant amount of racks, and I can't remember exactly how much it was, but it was like, I think it was like 48 racks at $750,000 a piece, plus all the equipment, networking to put it together, rack top switches, all this stuff, cables. I mean, it's expensive. It's super expensive. And here's another thing he's doing. He's just looking at the data sets. They might be using CPUs to compute this. They get the 52 billion edges per second. They're not using NV100s because it's only 60% faster. So this is like it's like comparing a CPU to a GPU. So it's not a perfect way to compare. Yeah. And then, so you have 105 racks down to one rack. Come on. That's not how it's going to go, really. If people are using GPUs, they're going to be using GPUs before they buy this. They're not going to be using CPUs and then go to GPUs. That's ridiculous. So that's the NVIDIA DGX A100, the third generation AI system. Pretty cool. Comes with, so NVIDIA purchased Mellanox. They made that very apparent. It's a network company. That one of the interesting things that I thought about this was they put a dual 64-core AMD Rome CPU in there. NVIDIA and Intel have been, the NV100 was built on the NVIDIA architecture. I think they went with the AMD architecture because of the PCI Express 4.0 connectivity, and the CPUs don't get nearly as hot. They're much more efficient, and I mean, with 64 cores, Intel can't even touch that at all right now. They're at 28 cores, I think, in one CPU. AMD's just smashing them in that regard. Then you have your 8 NVIDIA A100 GPUs. You have some NV switches. I don't really know anything about that. Then you have some 15 terabyte Gen 4 NVMe SSDs. Again, thanks to that AMD CPU that they threw in there. I thought it was a really cool GTC. It's very exciting going from 14 nanometer or 12 nanometer down to 7 nanometers on TSMC. And that's going to yield some really amazing improvements in the coming months. So come holiday 2020, you're going to have new GPUs out that are going to be much more powerful. So when you're purchasing laptops next year, or or if you're purchasing desktops next year, look for those Ampere, I don't know how to pronounce it, Ampere graphics, because they're going to be pretty amazing. And AMD is going to fire back. I don't expect AMD to be quite as powerful as NVIDIA. NVIDIA has had a dominating lead in the GPU space for a long time, and I imagine once they release this product, they're going to maintain that lead, but you will pay for it. So AMD's been fairly competitive when it comes to their Radeon series graphics cards, so they're probably going to remain competitive, and I'm really excited to see what they bring to the table. Well, that just about wraps it up. Like, subscribe, notification, you know what to do. We'll see you next time.